Hello everybody, my name is Anthony Sortino, and today I'm going to be talking about the Annihilator method and how it's used. So the Annihilator method is a method that we have used for solving ODEs, or we do use for solving ODEs. It's used to find the general solution of ODEs if we're given something in the form of equation in terms of y primes or whatever. However, today I'm just going to be discussing how to find annihilators of certain functions. The whole goal of an annihilator is to do exactly as the word says, to annihilate the function, which means we're just trying to get rid of the function and set it equals 0, or to turn it into 0. It is an operator, so we're applying an operator, and then we're just trying to annihilate the function. In this table here, we see some general annihilators for different types of functions. So this is just something we're going to be basing off our answers right here. So let's start with number 1 here, where we have f of x is equal to x to the 4th minus x squared plus 11. So in this case, since nothing's being multiplied or anything, we see that this function here resembles something in the form, I don't know why it just did that. Whatever. Now it resembles something in the form of t to the n. So anytime we're looking at a question like this, we always want to look at the highest degree, because if we annihilate the highest one, all the rest are going to also go away with that. So in this case, we have that our n value, I don't know why it keeps getting rid of those. Our n value is equal to 4. So we know that our annihilator, in terms of that general, according to this table up there, our annihilator is going to be d to the n plus 1. So if n equals 4, n plus 1 is 5. So this means that the fifth derivative of the function f of x, so the fifth derivative of f of x is going to be 0. So let's just check that out real quick and check. So we have f prime of x is equal to 4x cubed minus 2x. We have f double prime of x is equal to 12x squared minus 2. We have the third derivative of x is equal to 24x, and that goes away. We have the fourth derivative is 24. And then last but not least, we have the fifth derivative is 0. So we have confirmed that our annihilator to this function is d to the fifth. So that was a very easy one. Now we're going to get to something a little bit more complex. So we see here that our g of x function matches this last row of our table. So let's start writing down our values to get this all nice and ready. So we have our x squared. So if we look at that, we see that 2 is equal to m minus 1. Which means our m is equal to 3. Then we also have our r value is going to be equal to negative 1, since it's negative 1 times x. It does not seem to want to write. There we go. And we have our b, or beta value, is going to be equal to 2, and that's just simply basing it off of there. So now that we have all this, we're going to use the annihilator above in the table to create our annihilator. So it's going to be d minus r. Our r is negative 1, so it's a plus 1 squared. And then it's going to be plus beta squared, so 2 squared is going to be 4. And all that is raised to the m power. So we have that. So I can solve this one, but it's going to get really ugly. But I'm just going to show you what to do from here. So you might be a little confused, like, okay, well, what do we do here? How do we go through plugging this in? So anytime you're given something like this, where this is the form, if you want to prove that it annihilates it, you're going to want to expand it all. So in here, it's going to be, our a is going to be equal to d squared plus 2, oh gosh, there we go, 2d plus 1 plus 4, and all that is going to be cubed. So then we have a is equal to d squared plus 2d plus 5, all cubed. And then you would cube that. So then you would multiply all of them times each other 3 times. And then you would do the same thing we did for the first one, where we plug in for the thing. So in this case, I can do it real quick if we need to. It's going to be a lot of work. But basically, you just treat it as the derivative. So if it's d squared, it's the second derivative. If it's 2 times d, it's 2 times the first derivative. And then if it's 5, in this case, it's 5 times the whole function. But obviously, those numbers are going to change as we expand it. However, this indeed, if it wants to draw again, will be the annihilator to this function. Now, last but not least, this one may be a little bit more confusing than the rest. So this one looks very simple because we see, okay, well, this is x e to the 2x, which is something very similar to our fourth column. Or, well, when I count columns, I'm counting from t to the n. So we see x to the n minus 1 times e to the rx, which is this first part right here. So we see that that actually does work out for this one. However, it won't get rid of this negative 7 out here. So we need to find a way to do that. We know, however, that the annihilator... Oh my gosh, this thing really does not want to draw. Come on. There we go. Okay, that's too much. We see the annihilator of this is d, and we know the annihilator of this right here is going to be d minus our r, which in this case is going to be 2, raised to the m power, and we know m is going to be 2 because it's m minus 1. That's going to be, there's an imaginary 1 right there, and we have m minus 1 is equal to 1, m equals 2, and that is seen from this one right here. This one right here, at the top of the screen, sorry. Okay, so now we have that. This is actually going to be a great example to show how you would go about solving the question we just did before this, because this actually works out quite nicely to demonstrate how that works. Ignore all those little splotches out there. That's from me trying to write. So let's test this out. So we have d squared then minus 4d plus 4. And this is just to annihilate this first part. So in order to annihilate the whole thing, we need to multiply by this d. So this d right here is also important to doing that. So we're going to have to multiply this whole thing by d. Well, we also multiply this one by d. So these two would be the annihilators to this function. Now I'm going to go through that real quick and prove it. So we have d cubed minus 4d squared plus 4d should theoretically annihilate this function. So if we have h of x is equal to x e to 2x minus 7, h prime of x is equal to, we got a product rule here, we have e to the 2x plus 2x e to the 2x, and we have h double prime of x is equal to 2e to the 2x plus 2e to the 2x plus 4x e to the 2x. And we have h triple prime of x is equal to 4e to the 2x plus 4e to the 2x plus 4e to the 2x plus 8x e to the 2x. Lots of stuff going on here. That should be a triple prime. So, now that we have these, all we have to do is plug this into the function. So we see, okay, well, d cubed, that's going to be this long triple prime thing right here. So let's write that out. 4e to the 2x plus, no, we can combine those real quick, so let me just do that. 4, 4, 4, that's 12e to the 2x plus 8x e to the 2x minus 4 times our second derivative. So once again, I'm combining like terms here. We have 4e to the 2x plus 4x e to the 2x plus 4 times our first derivative, which is e to the 2x plus 2x e to the 2x. We got that done here. Now we simply just distribute, and we're going to see that all these things are going to cancel very nicely. We have 12, that, 8x e to the 2x minus 16 e to the 2x minus 16x e to the 2x plus 4 e to the 2x plus 8x e to the 2x. So now you look at this, okay, well, we have a 12 e to the 2x, so a positive 12 minus 16, we are now at -4 plus 4. That cancels out, so these three are going to zero out. Then we're going to look at these two. We have a +8, that's 16, minus 16, that's 0. And as you can see, this whole entire equation is equal to 0. So that's how we have proved that this right here is the annihilator of our function. Hopefully you learned something. If you already knew it, awesome. But that's just a little bit of a proof on how these annihilators work. Thank you for watching and have a great day.